how did that happen? Well, turns out atmospheric pressure crushed it. Turns out that the atmospheric pressure on the Earth is a constant. It's pushing on us all the time in all directions. We don't notice it because it's happening all the time. Well, if pressure is a constant, then force divided by area must also be the same number every time. Well, let's multiply by area, and that would give us how much force there is. Let's imagine that A is 1. Well, if A is 2, notice as the area is getting bigger, the force is getting bigger. So that's why when there's more area, there's more force on it because the pressure is a constant.
So here we have a tub of water. This is to illustrate the concept of pushing and pulling a fluid. As you can see, you can't pull a fluid.
But you can definitely push one. Here's an example of atmospheric pressure holding up water. Since the card has area and pressure times area gives us force, the atmospheric pressure can provide a force to hold up this water.
So how much water can it hold?
Well, that's a great question, Abhi. Turns out it's about 10 meters or about 35 feet, which is a little higher than the height of the school.
How does the suction cup actually work? You may think that it's pulling something, but as we've already seen, you can't pull a fluid. You can only push it. So that when I take suction cups and I put them together, notice they're not holding each other together. There's no adhesion. There's no glue. However, if I take them and I put them together and I make a vacuum inside where there's less pressure inside and more pressure outside, atmospheric pressure will push them together like this. Okay, we just put these suction cups underneath here. The 2x4s are to give it strength so it doesn't collapse on me. And as we saw before, there's absolutely no adhesion on the suction cups. That's just atmospheric pressure holding them up. And because they're so large, they're strong enough for me to elevate myself just using atmospheric pressure. Those suction cups will hold up about 240 pounds each because of their size. As we found out, air pressure is a constant. The bigger the area, the larger the force. Well, now instead of that aluminum can we started with, now we have a paint thinner can, which is a lot more solid. So why are we boiling water? You can see the steam coming out. We need to lower the pressure inside the can so that atmospheric pressure can push in. That's known as a pressure differential. So we boil water, and as you can see, it's expanding out like any gas would with temperature. And then when I cap it, take it off the heat source and put it in something cold, cold ice water, the gas is going to compress and atmospheric pressure will do the rest. So we get a good seal on here so that no air can get in from the outside. Look at it, it's already starting to collapse. And on Goblin Day 2014, we're going to take this 55-gallon drum, which as you can see is very strong. We're going to crush it with atmospheric pressure. We're going to boil water inside of it, put it into a pool with ice and water, and atmospheric pressure will do the rest. It is very strong. This is pretty thick steel. However, its area is big, and since the pressure pushes everywhere, bigger area means more force, and atmospheric pressure has more than enough force to crush this. When are we going to do it? Right after the pep rally on Goblin Day out in front of the school.